Okay, and then I think we can run the regressions. So this is an OLS regression. The keyword is regress. And then space followed by the Y variable, which is log real per capita income. Explained by province. We must leave our Western Cape as reference dummy, so I have to include the other 8 provincial dummies. As I said, you can manually type the variable names, or you can just double click from this variable list. And then race, let's leave Africans as reference categories. Then colored, Indian, white. Gender, let's go back to the answers. So we include a male dummy. So in other words, female dummy is left out as reference group. So I include male dummy. Education, let's say the none dummy will be the reference group. Then I include primary, secondary, matric, certificate diploma, and bachelor degree dummies. And then age, let's say the youngest age cohort is left out as reference group. So I include the other age dummies. And according to the questions, we still have to include household size and the employment dummy. Okay, so household size and then the employed dummy that indicates whether the household head is employed or not. If you think you are ready, then you can press enter. Okay, and then you can see the R square, adjusted R square, computed F statistics, and so forth. And this is the probability value. Okay. So we can just randomly interpret, let's say, this one. I think this is a log-lin model, hey? Log-lin model. So in order to interpret the parameter or the coefficient, we need to multiply by 100. So for this one, it means if household size increases by 1 person, ceteris paribus, then on average, this regression predicts that log real per capita income, real per capita income would decrease by 14%. I think it makes sense. Usually, larger household size might imply money metric poverty. Okay, it means members from different generations, multi-generational households. Many members live together, overcrowded. Okay, so that implies poverty. So the higher the household size, the lower the income. Okay, and then let's say if we look at these education parameters, you clearly see as we move across to the more educated categories, then the coefficient becomes larger. It makes sense because high educational attainment is associated with higher earnings. Okay, happy with that? Next one, we want to run a probit regression on poverty. So this is the poverty line, 8268. So if your earnings is above or below, let's say 1 stands for poor, 0 stands for non-poor. So let's generate this poor dummy. So first of all, I assume everyone is not poor. So the poor dummy equals 1. Poor dummy equals 0. And then replace poor equals 1 if we go back to the question, real per capita income is below 8268. If real per capita income is below 8268. Okay. So the real per capita income is below this threshold, then the person is defined as poor. So remember, if poor equals 1, it means the person is poor. Okay. And then according to the questions, we run this probit regression on poverty likelihood, but using exactly the same explanatory variables as the previous OLS. So what you can do is just click on the OLS regression command here. Then all you have to do is just to change the keywords right at the beginning. This time it is not OLS, it is a probit regression. So probit poor. Then exactly the same explanatory variables. Okay. I just want to make sure I get the same answers as in the handout, 0.395 something. Yeah, exactly the same. So we can interpret the answers. Okay, so if we look at these provincial dummies, so they are all positive. So it means compared with the reference group Western Cape, people living in other 8 provinces are significantly more likely to be poor because the probability value is below 5% actually. And then let's look at these dummies. So you see the negative parameters, not surprising because it means the higher the educational attainment, the lower, and actually the result is statistically significant, the lower the likelihood of poverty. And then let's move on to this one. It means if the household head is employed, then poverty likelihood significantly decreases. You see the negative coefficient. Okay, so we have learned how to run OLS and probe it. Okay, the next one is the FGT poverty indices, which you should have learned. Let's say you have done development economics using the same poverty line. So I want to derive poverty headcount, poverty gap, and square poverty gap ratios. So this is the keyword prof deco, poverty decomposition. Using which variable you need to specify real per capita income. And then by province. By province, PL means poverty line 8268. I think it is 8268. Okay. Let's hope I typed the command correctly. It has been a while since I have run this type of command. Okay. So this is the overall results for the full population. So that is your P0. It means 33% of the overall population, they are poor. I think I have exactly the same answers here. Okay. And then to look at the provincial results, you have to look at here, once again, the FGT indices. So these are the answers. So what I did was just to copy and paste to Microsoft Word. So let's focus on P0, poverty headcount ratio. Then it means it is the smallest in Western Cape. Okay. So it means only 18% of the Western Cape residents are poor. Then we can do it by race, gender, and education. So just click on the same command, but I just make a bit of a small change here, this time by gender. It is still the same poverty line. Okay. So poverty likelihood is lower for male-headed households. Then we can do it by race. Again, just check the results under FGTs. Okay. Okay. So that's the answers. Last one by educate. Okay. This one is interesting. If you come from a household that the household head never went to school, see how high the probability is to suffer poverty, more than 50%. But if you come from a household headed by someone with bachelor degree, you only have 2% likelihood to be poor. Okay. Then the next one is Gini coefficient. You have got two ways to work out the Gini coefficient. The first one is INEQDECO, inequality decomposition. Real per capita income, again, by province. It takes a bit of time, actually. We only need to worry about the Gini coefficients. The rest are beyond the scope of this workshop. Okay, so this is the Gini coefficient for the full population. You see the keywords here, all observations, so 0.72 something. Okay, and then one issue with the inequality decomposition command is it automatically excludes people with 0 per capita income. Do you see the sentence here? 71 people with zero per capita income, not included for the calculation. So this is a small flaw of this combined inequality decomposition, because strictly speaking, we should include everyone. And then these are the Gini coefficients at each province. Then we can do a few more. I'm not going to do all of them. Let's do one more, one or two more. Let's say by race. Again, starting off with the national Gini coefficient, including everyone. Then I think you can notice the racial Gini coefficient. Okay, so Gini coefficient is the highest for the African population. It is not surprising because a lot of empirical studies have found a problem called within race inequality. It has become more serious within the African population. So I will do one more gender. I'm not going to do the one by education. I will leave it for you to do it. Okay, you can see more or less the same, not much of a difference by gender. Okay, and then the other way to work out the Gini coefficient is, it is a bit strange, it is called in equals 7. Real per capita income. Then you might wonder, does the combine look something like that? In equals 7, real per capita income by province. For this in equals 7 combine, it includes everyone, including those with zero income. Remember, I mentioned earlier, we have to, strictly speaking, we should include everyone, regardless of how much they earn. And this is the flaw of this in equals 7 combine. The by option is not allowed. So in other words, it will be a bit time consuming. We have to do it one category at a time. Okay, starting with Western Cape. So this is the Gini coefficient. And then we have to do it for the next province. So it's the small flaw of this in equals 7 combined, but it includes everyone. Okay. I will just do it by race. I'm not going to do it by gender, and maybe I will do it by educate later. So again, looking at the racial Gini coefficient, I think it is once again the highest for the African population. Okay. And then let's do it by educate. Okay. So we finish up to 8. So now you know how to run OLS, and first of all, how to generate dummy variables, okay? And then how to run OLS and then probe it. So remember, for OLS, the combine, the keyword is regress, and then for probe it, you have to start off with probe it, and then followed by the Y variable, and then the explanatory variables. And you also know how to derive the FGT poverty indices, as well as the two different ways to calculate Gini coefficient. Okay, so we are going to take a break, and then afterwards we are going to do this long revision exercise. Okay, so it is really a good recap of what you learned in the last 2 days: statistical analysis, graphical analysis, and econometric analysis. So you have one more chance to learn the tedious process, time-consuming process to generate the dummy variables. And you need to pay particular attention, careful attention to the generation of the age cohort dummy variables. Okay, so we are going to do it after the break.